The Sun by Jennifer Lettner. An introduction to the Sun. The Sun is at the center of our solar system, and all the planets revolve around the Sun. The Sun is the source of energy for all life on Earth and produces large amounts of energy and has multiple layers. Though the Sun is small for a star, in relativity to the stars out in the universe, the Sun's diameter is 1,391,980 kilometers, which is about 109 times as big as the Earth, and more than 1 million Earths could fit inside of the Sun. The layers of the Sun. There are layers of the atmosphere and of the interior of the Sun. The layers of the atmosphere are the photosphere, chromosphere, transition zone, and corona. The photosphere is the layer that emits the radiation that we see. The chromosphere is the layer of decreased density above the photosphere. The transition zone is the layer of greatly increased temperature, and the corona is the outermost and thinnest layer. The interior layers of the Sun are the convection zone, radiation zone, and core. The convection zone are superheated gases that are continuous thermal convection. The radiation zone is where energy is carried towards the surface without the aid of convection. And the core is the site of high-energy nuclear reactions that generate the Sun's enormous energy output. Two of the requirements for this nuclear reaction are the high density and heat that the core of the Sun possesses. Solar winds. The corona of the Sun reaches temps in excess of 1 million Kelvin, and therefore the molecules in this layer have enough energy to escape from the Sun's gravity. These particles have very high energy and form what is called solar winds. Luckily, the Earth is protected from these solar winds by its magnetic field. These solar winds and other solar activity are what cause the aurora borealis at the Earth's poles. Solar magnetism and sunspots. Sunspots are dark areas in the photosphere. The sunspots are only dark relative to the surface of the Sun. If a sunspot could be suspended in space, it would shine 10 times brighter than a full moon. The sunspots can rotate, and so this affects the magnetic field. The sunspots average 1,000 Kelvin cooler than the surrounding photosphere and 1,000 times stronger magnetic field. Due to the Sun's rotation, the field lines do not run directly north and south like the Earth's. The plasma in the Sun does not rotate at the same rate, which causes the field lines to get all twisted up and not be straight. This different rotations of the Sun drags the lines and creates kinks that are where the sunspots form. The sunspots normally come in pairs of opposite magnetic charge. Solar cycles. The Sun goes through 11-year cycles of high and low sunspot activity. We are currently in a low point. The number of sunspots is linked to the amount of material that is ejected into the solar system. As you can see by the graph, there are more sunspots every 11 years. Prominences are large sheets of material ejected from the Sun in loops along the magnetic field lines. An example of the prominences is shown in the top picture. Solar flares are ejected material like a prominence, but in a matter of seconds or minutes, and it occurs when a sunspot releases its energy. A sunspot releases as much as 1 billion megatons of energy when it starts to come apart. And that is all.